Today I will be talking about our meeting. Of course, the main part of the presentation it belongs to Thomas, but I would like to tell about a very important event. Yesterday we talked about who was present here before. I've been working for 10 years in Kaspersky labs, and we were talking about our research. Now I'm on the side of IRC, and I would like to tell you about what happens in our company. Today is a very important day for me because today on this platform I announced the opening the IRC operation in Russia, and we would like to support you, to help you, and I feel very excited. What are we going to tell about today? I'll talk about our operations start in Russia. We'll take about industrial cybersecurity. It will be an important part of our discussion. And now, just briefly, I would like to tell you about what is IRC and how the company is searching the market. Of course, first of all, it is a big range, vast range of services. Secondly, it's a huge amount of markets. Of course, you all are aware of IRC is a pretty narrow professional niche of automation and security, and we cover it geographically by products, by technologies, by hardware, software, firmware, everything. And you will see that we work with a great number of serious companies, and today and now we begin consulting the leading Russian companies. Also, our partners are big industrial vendors and suppliers. And one of the directors of industrial vendors mentioned yesterday who does not work with IRC. All the big companies are working with IRC. You see them all on the screen. Huge number of pleasant comments about the results of projects. This is a great support of our customers. And on this slide you can see a large list of projects which are being issued this year. So you will be all able to find solutions to and answers to your questions. And to summarize, I would like to mention again that I'm really impressed and excited of IRC beginning operations in Russia, and I'm sure that with every one of you we will have discussions. All of you can ask your questions and get answers to them, how to change the processes, what figures are on the market, how our enterprises are changing. The world is emerging fast, and now we are here to let you lead in your market, to know your trends which are happening on the market, and that so that Russian companies would be leaders in their spheres. Here we are for that purpose. Thank you.
Back to the presentation topic, and the topic is really the digitalization in the industry an opportunity, or is it a risk? And I have at least 3 takeaways for you today from this presentation you have to think about. Plant availability and safety is one important topic. The human factor regards digitalization and implementation is a very important factor. And of course, the integrity of the data. So let's look into the automation markets. Let's look into the automation expenditures. And what we can see, and this is a simplified view of EMEA, so the biggest portion here are the DCS systems, these are in the control layer, followed by the sensors and actors layers. Here are the control valves, very expensive devices, and last but not least the software bits, the MES systems. So again, it's a simplified view, but keep these numbers in mind, roughly $30 billion in EMEA. And this spending is not everywhere similar in the world. So the biggest part of the process automation spending happens in EMEA. And this is not just the spendings, it is much more, because EMEA quite often provides global standards and recommendations. So we are here quite, let's say, analytical, and we are doing a lot of investigation. We are providing standards, regulations, and these kind of stuff. Okay, and now we can do simple mathematics. So sorry to bore you with this, but coming back and bridge the topic to the ICS, cybersecurity. Because if I do the ratio, if I do the math regards the 2017 market numbers, I have investments in cybersecurity of roughly 900 million divided by roughly 30 billion total process expenditure. That gives us a ratio of more or less 3%. And this 3% is not good, is not bad, but these 3%, they really indicate the main investment is done in endpoint protection, is done in malware recognition, so virus scanning, this kind of stuff, blacklisting. And it's quite often a one-off exercise. Security is implemented, and that's it. And this is maybe not good enough. And why is this not good enough? We are going to discuss this later. So first of all, I would like to discuss with you what is the question, or what is an effective defense? How looks an effective defense like? And this is definitely one approach. Simply, in case of a cyber attack, break the glass of the cabinet and pull the blue cables. Yes, it's maybe manual interaction and foolproof, but not sure if that is the right way forward. So we at ASC, we feel it is really better to have a structured approach, and this structured approach is on the right-hand side. And it is important in this structured approach really to analyze the likelihood being attacked, the so-called security level, and then design your security measures according to these results. And later on, do a, let's say, frequent audit due the planned life cycle to really evaluate that the security appliances are in line with the actual threat landscape. So we feel that is a much better approach than just rely on the glass cabinet and break into it, and that's it. Because let's discuss what is the view of the attacker of a process automation plant, and you can see that on the left-hand side from your end, because the attacker sees only three main items. He sees people, networks, and devices behind the industrial fence, behind the fence of the process plant. And he thinks about how can I attack this installation from the outside, or even better, sometimes easier, from the inside. And now I'm coming back to my previous statements. I said, please consider data integrity, the human factor regards cybersecurity and the plant availability or plant safety. And this is nice explained here on the right-hand side from your thing in the green table, because if you compare the normal office IT environment with the ICS IT environment, you will find dramatical discrepancies. So especially the network bit is completely different. So Office IT is using mainly Ethernet physical layers with open protocols, but in the ICS works we have much more. We have proprietary networks, proprietary communication, and we have to think about people. In the Office IT world, you have normally educated administrators. They are able to maintain the systems, more or less. But in the ICS world, you have mainly engineers, you have operators, you have plant owners, and they are quite seldom well prepared to maintain the security. And of course, the goals are different and the constraints are different. So with other words, we have to rethink the process. So even if the level of security is good enough today, I'm in doubt that this is good enough tomorrow, because our plant is changing thanks to digitalization, and changing means this. On the bottom left, in the blue field, there's this existing good old process application plans. We're adding now edge devices. That means more clever devices. They have local intelligence and local computing power. And we are connecting all these devices to each other to enable new business modules and use this edge functionality to do, let's say, condition-based monitoring or this kind of stuff. So with other words, we do an ubiquitous networking with all the components, and that is changing the world. I think in our keynote yesterday morning, we heard the data is the new gold. That is true, but only if you secure the integrity of the data. Because if this data is not longer more belong to you, then you run into issues. And I think Ferrari said today something similar. So we have to think seriously about this. So what is the right, let's say, methodology or corrective action to secure our plant? And we at ASC, we feel that is a possible approach. Really, we start on the bottom with the cyber assets. This is the area where in EMEA the 30 billion are. On top of that, we are doing the proven in use endpoint protection and network security. That is the stuff we already use. But on top of that, we do cybersecurity management solutions, and cybersecurity management solutions could be then really the auditing, the life cycle management, the audit over the plant life cycle, and on the top, we are using third-party competencies to even secure our plant further. And I think that could be the right future workflow. Everything is new, digitalization is new, edge devices are new, ubiquitous computing is new, and so we have to change our ICS approach as well. And that is one possible approach. This is reflected in the actual numbers as well, because if we now look into the global market numbers of ICS security, we will find that these new services, the network security solutions and the anomaly and breach detection solutions, they are quite on low numbers. That means they run into early adapter mode, so people try it out, they're piloting these kind of activities, and that is absolutely in line with our research results, because we feel it is good to understand this kind of methodology before you use it everywhere, and that is exactly reflected in the numbers. But let's summarize what is exactly the change and what are the details of the change. And to answer this question, we have to discuss this little picture from the right to the left. Let's start with this famous edge device, the little red thing here. And what is an edge device? An edge device is something very simple. It is a physical sensor, for example, temperature transmitter. And you add a little microcontroller with an interface. Interface can be wired or wireless. And a general purpose I/O functionality and a little bit storage to submit a software code. So, and with this edge device, so the edge device is then the combination of this sensor with this little microcontroller and the functionality, you have an intelligent device. And these intelligent devices, they can be integrated into other things. You can update it, for example, SCADA systems, little PLCs. You can do multi-purpose sensors and whatever. And with that, you have a so-called embedded system approach, and you can then combine these systems all together in one plant, and maybe you can connect all these plants to a big thing to have a remote facility or whatever. With other words, everything is connected to anything. And this can be really strange because this looks like that. And that is really the Wild West topology. And you have to be very careful because our classical methods are not good enough to give recommendation how to do endpoint protection, how to understand breaches into the networks, and how to react. So, and that is exactly where I feel we have to rethink, because we have here on the bottom our edge devices, sometimes isolated, sometimes combined to new functionalities. In the middle, we have really the cloud layer. The cloud layer is nothing else than a big server farm which collect all this data. And on top of that, you have new apps and services sometimes provided by third-party suppliers. And they are using the data, they are doing data analyzing, they are the data scientists, and offering bespoke service to the analyzing results. But these complex networks that needs protection, and again, I'm coming back to my initial statement, data integrity is really an important topic here. So you have to think carefully how to achieve the data protection in this kind of environment. A different view of that, but in principle similar, is the ubiquitous connectivity. And you see all the different things connected to each other. You have the cloud services on the left. You have the suppliers and service providers left top. And then you have more devices and smart customer devices, remote intelligence asset on the right-hand side. So that is more, these are more or less the use cases of the network we have seen before. And at this moment in time, you have to ask yourself, if I implement such an environment to increase the efficiency of the plant, and we have heard yesterday, we cannot stop digitalization. Digitalization will come. So we have to react, we have to think about what are we going to do. And we have to do things differently, otherwise we are running out of control. To summarize that, so cybersecurity is, from the ASC point of view, the key concern for the deployment of digitalization. And I'm not meaning here the piloting bit. Many customers piloting, they're piloting in a sandbox, in a safe environment, and they feel it is a good approach, but as long as the cybersecurity question is not really answered, they're not going any further. Customers, asset owners, the 30 billion of investment, they need guidelines, they need recommendations, they need best practices. So they want to get really a guideline how to go forward on what is proven in use security. Because it is really wrong to hope that asset owners will delay this implementation. They're not delaying it. We have to react. And I think we are now in the driving seat, because we as the cybersecurity experts, we have to develop concepts to survive in this kind of environment in the future. And let's discuss briefly who are the attackers, because it is not as easy. Here on the top, you see typical groups. You have general hackers, you have hacktivists, you have cyber criminals, terrorists, or unfriendly nations. And each individual has been mentioned before already. And we can simply group these. We can say the general hackers and the hacktivists. These are maybe people, these are IT-savvy people. They're not really experienced with process applications. Then we have people who are really have process knowledge, and say we have to treat them differently. The likelihood being attacked of the hackers or hacktivists is quite high, but on the other hand, the impact, what they are going to achieve, is not as much compared to the cyber criminals or the terrorists. The capabilities and resources are, of course, unlimited to unfriendly nations. I think we have seen examples before. And there's one other aspect, and this aspect is really serious, because the hacktivists, cyber criminals, and partly the terrorists, they could be insider. They could be already part of your team. And you have to be careful if we have, let's say, demotivated people. They have maybe the skills and opportunities to attack their own plant. To survive in this kind of environment, you need really cybersecurity management, and that starts with simple patch management. You have to think about how to monitor the plant, and you have to do it over the life cycle frequently. You have to remove malware, you have to you have to be in control who has access to your control systems, backup functionality, and monitoring of the threat landscape. So you have to do really security awareness over plant life cycle, and that is maybe the last bit of the human factor. Everybody knows that, everybody agrees that is required, but only few people really doing it. Let us talk. Thank you.